bases, and our lovely salts. So you got the nice piece of paper and sort of make a little window. And this is a neat thing that I just learned about. It reminds me of like a Venn diagram, so you can do one side one thing, one side another, and sort of like blend the two concepts. So another neat idea to take in other classes. So, and then one side, if you want to write acids, and another base. And that's where we're going to take our notes for each respectable acid and base. All right, and some things to know before we start. Red and blue litmus paper, which we'll be playing with later. We've got the red, so yay. And then phenoliphthalate. Are we using that? Yes, we get to use that too. I've heard of that. So they're both indicators, which means they have carbon present in them. They're organic substances. They'll change colors when they come in contact with acid. So, basic information on that. And like sometimes they're liquid and sometimes they're solid paper. So, and so acids give up hydrogen ions. So your hydrochloric acid will shoot off those hydrogen ions when it is in a solution. These ions bond to water molecules from hydronium ions, and for today's purposes, think of hydrogen ions and these hydronium ions as the same thing. So, I'll move. There we go. Nope, other way. And the more hydronium or hydrogen ions in the solution, the more acidic it is. So if one solution has one hydrogen ion and the other has three, which one's going to be more acidic? So properties of acids. So they taste sour. Lemons, I love lemons. I love anything sour. I love Chick-fil-A's lemonade. Best stuff in the world. It causes the litmus paper or the phenolphthalein to change colors. And they can conduct an electrical current, which is fun if you've ever electroplated. It's a neat little thing to do. Stripping copper ions from copper, or not ions, copper, and put them on a quarter. And it can cause corrosive damage. So some common acids are tea, which is really amazing, and that's tannic acid. Citrus juices is ascorbic acid. Vinegar, acetic acid, which is really good on spinach. Soda, which I need to quit drinking, is carbonic acid. Aspirin, not going to attempt that. I think it's acetylsalicylic, roundabout. Acne medication, salicylic acid. Oh, go back. We got strong and weak acids. And acids ionize when dissolved in water, so they break apart charged particles. And an example is our hydrochloric acid. It's in the hydrogen ion, separated into the hydrogen ion, and then a chlorine ion. So put in that solution, it's separated into those two ions. And the next one we have is carbonic acid, and it's separated into hydrogen ion and bicarbonate ion. So, and who remembers how to tell if one's stronger than the other? No?
Muscles.
Muscles. Yeah. One has more muscle than the other.
Would it give off a more vibrant color?
No.
What?
Yes. Yep.
Would they get their pH, like scale?
Yes. What's the pH scale measure?
They're proteins.
1 to 14.
Huh?
Proteins.
1 to 14.
Close. That's the scale. Yeah.
So, let's say if an acid was 2, it would have a more acidic. It'd be more acidic than an acid with a number of like 5 or 6.
Yep. We're fast forwarding though.
Does it have something to do with the number of ions?
The number of
Hydrogen ions.
yes, the number of hydrogen ions. So, which one of these guys is stronger?
The second one.
The second one.
I had asked her for help on this. So, what she said to me was, since the first one, all the hydrogen is awake, like the hydrogen and the chlorine ions are separated, that one will be stronger because there's no hydrogen connected with the, like the lower one, the bicarbonate ion. It has a hydrogen, so it's weaker.
Oh.
So the more hydrogen ions you can pull off of the acid, the stronger it is. Esters. Esters are compounds that form when an organic acid reacts with the alcohol, and the result is ester. And they're commonly used in perfumes and smell, like flowers and fruits. And I guarantee a lot of us are wearing polyester. I think this is polyester, but it's long chains of esters. So, nice, cheap, man-made material. Now we got bases.
Can you go back to this?
Yeah. So bases are opposites of acids. Instead of the hydrogen ion coming off, it is the hydroxide ions that pop off in the solution. They react with water, or they react with acids to form water and salts. And properties. They taste bitter. They feel slippery. Cause indicators to change colors as well. And a common one we use is baking soda. And I had to take supplemental baking sodas, like a tablespoon with every meal, because my body is way too acidic. So, don't have an acidic body.
Is that not fizzing?
Yep, it's like like eating a spoonful of very finely grained salt. And hand soap.
That's the things that will give me nightmares.
It wasn't my doing, I promise.
Oh, excuses.
So those are some common bases we use around the house. And some more common ones are antacid tablets, laxatives, toothpaste, ammonia, soap, and deodorant.
Let's go to
The pH scale.
ammonia and ammonia.
Yep. Strong or weak bases. Bases ionize when dissolved in water, and they break apart into charged particles. So here it is sodium hydroxide. And our sodium hydroxide is separated into our sodium ion and our hydroxide ion. So there's the OH that it popped off. And we have our little sodium floater. And then another one is ammonia. And it broke up in, once placed in water, broke up into ammonium ion and a hydroxide ion. So, which base is stronger? Yeah.
Would it be the first one?
First one. Yes. Oh. Yes. I'm so used to correct answers being there when I come through. It is. Because all the OH is off and there's no. So here's where our pH begins, and we can draw like a scale at the top from 1 to 14, and then do a little inner tabs, and underneath that we'll start some notes, and then we'll fill in a nice little pH chart. So pH is a mathematical calculation of hydrogen ion concentration in the solution. So when I had to see how acidic my body was, I actually spit into a spoon and then tested it with litmus paper. And it was I had to see whether or not to take that spoonful. And it's measured on a scale of 0 to 14, so I made a mistake. And there we go. There's like a sample. So the acids, like battery acid, is on the far left, and then lemon juice, wine, normal moraine, and regular water, tap water, is usually around 7. Distilled water is at 7 pH. And then we go into the bases: baking soda, soft soap, ammonia, and lye. So, a student mixes strawberry Kool-Aid and water. A pH meter is used to measure a pH of 5.4. What kind of solution is this drink?
An acidic solution?
Yep, it's acidic. And the Kool-Aid mixture, what must there be more of, hydrogen ions or hydroxide ions?
Hydrogen ions.
Yes. So student adds Alka-Seltzer to Kool-Aid and stirs. The pH meter now reads 8.3. What was released?
Hydroxide ions.
Yeah. This is the last one. Baking soda is a weak base. Hydrochloric acid is a strong acid. What would happen if the two were mixed together? Yeah?
The acid would override the base.
Yes. What would the common?
Acidic.
It would still be acidic, but would it be a strong or
Weak.
weak?
It would not be a strong.
No.
So wouldn't it also form like water itself? Since you're acidic base and the acid.
I'm not sure. It would. It would.
But it'll still be completely acidic.
Yep. So it would make a nice weak acid. Because the base sort of takes away some of the strength of the strong acid. On the end.
Yeah.
If I can get it.